Am I audible or not, sir?
Yes, sir, you're audible.
Thank you.
Sir, Abhinav, we can start now. Most of the people are joined.
Okay, sir. Okay. So again, good evening, everyone. Welcome to the session
Good evening, sir.
on our first project. Okay, so uh, did you people get time to try this? Look into it, have some thought or anything? I know it's only one day. Most of you may not get the time, but at least I think you must have thought about the question, like what we are dealing with and all.
Get
Uh,
down actually.
yeah. So no problem. I'll start with the basic itself. I'll start to share my screen. Is my screen visible, sir?
Yes, sir. Yes, sir. Very much.
Okay. Okay. So to start the session, so as discussed in the like in the on Sunday, like we discussed, we'll be dealing with the brake control. So here our objective is to first find out the yeah yeah
It's okay. It's okay.
what happened?
It's okay, sir. Now the audio system
Oh,
is
okay,
now it is okay.
okay. Yeah. So as discussed on Sunday, we'll first try to model our system, the braking system, with the help of the frequency response data.
Hello, Moto.
Hello. Okay, sorry.
Please switch off the mics here. Please request.
Yeah. So we'll first start with modeling the system, trying to find out what kind of a system, and exactly to point to narrow down to the transfer function, right? With the help of the frequency response data as well as the step response data. So first, what we'll do is we'll check if our system can be approximated as an LTI system with the frequency response data. Then, with by plotting the Bode plot, we'll get to know which order of the system it is. And finally, once we have the transfer function of our system, we'll design a PI controller to get a required performance by plotting the root location. So first, if I'll share my MATLAB screen itself, just a second. Just a second. So from the files I shared, yeah, from the files I shared, there are totally 3 files. Apart from the PDFs, there are 3 files, right? One is the frequency response data, another is the step response data, and a MATLAB script file I have shared. So now, uh, first we'll load the data just by double clicking. I suggest that you parallelly try to do along with me, so that if there are any doubts or anything, you can ask right away. Okay, so we have loaded the frequency response data just by double clicking. And first of all, I hope everybody is using MATLAB online itself, right?
Yes, sir. Yes, sir.
We are using online only. Yeah.
Okay, okay. So were you able to get the files I uploaded to here, your files on the MATLAB online window?
It's a bit difficult, but we are getting it done. So just give us 5 minutes. We are just doing it.
Yeah, yeah.
If possible, sir, please. It's a request.
Yeah, yeah. I'll no problem. I'll tell you. So here, when you click on MATLAB, this side panel, this kind of a window will open, and here you can select on this MATLAB drive. When you go to MATLAB drive, here MATLAB drive will have all the MATLAB drive is just like Google Drive, how you have an online storage, right? So MATLAB also has its own drive. So whatever files are there, you can upload here from your system. So you can download it from the Google Classroom and upload here. So they'll appear right away. So I have put them under a folder called Brick Project. Okay. So then once you do upload it there in the MATLAB drive, they'll directly appear here. Let me know if there is any difficulty.
Sir, we have to download that file and then upload it again in the drive, right?
Yes, you download it from the Google Classroom and then upload it here in the MATLAB drive.
Yeah.
We're doing it, sir. Just hold. We're just doing
Yeah,
it, sir.
sure. No problem.
Sir, we are in so we are using company laptop now, sir. It is not able to upload it from my system. So
Can we use the offline mode, sir? If it is because we have offline mode.
Yeah, sure. I thought you were comfortable, like when the last time we met, you're comfortable with MATLAB online. I thought you were using this. Anything is fine. If you are using the install the files, no need to upload in the drive or anything. You can directly set the path here. You can set the path of where you have downloaded the files here, and then that will directly, those files will directly show. Let me know once you have reached to the stage where the files are appearing here. Okay.
yeah, we are trying, sir. We are trying. Just
Right, sir. Right, sir. Just
Yeah.
we're doing it.
Yes, sir. Install.
So basically, sir, we have to go to MATLAB Drive and then just give the path, right? Upload the file over there.
Yeah, once you upload the file over there, it will directly show here because
So basically,
here,
sir, we have to go to MATLAB Drive and click New, right?
click new.
Just a minute.
You can
And
see
in
the
the
option
same
to
folder,
upload,
it
right?
is working.
Yeah, MATLAB Drive is there, so you can directly upload here. I have just created a new folder and uploaded there. That's the only difference. You can directly upload it here.
Okay, MATLAB Drive, I'm not able to find actually. Okay, just a minute.
So when you open the MATLAB online,
Or here itself, sir, in the files option is there, right? The previous window, sir. Here itself, right click and upload file option is coming. That is also working, I guess.
here,
Upload files. Ah,
okay. If it is, yeah, okay. Here also you're able to upload. Then that is fine. Yeah, I think this is much
yeah,
easier.
yes.
Sorry. Okay.
Okay, so to just go to
How did you go to that?
Writers.
class is running.
Sir,
Yes.
this window is there, the home window of MATLAB in online. So in that, this file section is there. In that,
Yeah.
somewhere if you right click, that
Yeah.
upload
Here.
files option will come.
Yes. Yes.
Yeah, like this.
Upload files and you can directly upload. Yes.
Yeah, I could
Thank you.
upload, sir. I could upload.
Yeah.
No
So you
problem.
are able to get the files here, right?
Yeah, frequency response data, frequency underscore response underscore data dot mat.
Huh.
Okay.
And step response data, that also you please upload.
Okay, sir. That I'll do.
And my spectrum also. These are the 3 files I put it on the class.
Right, sir. Right, sir.
So the extension of the file says what kind of a file it is. So .m means it is a script file, and .mat is a MATLAB data file. So like that. And one more request I have, please call me Abhinav itself. I'm much younger than you all, so don't call me sir.
Sure, sure, sir. No problem.
Sir, frequency response data, step response data, and then my
My
spectrum also, sir.
Yes,
Right,
all
sir.
these things.
Right, sir. Right, sir. Right, sir. Okay.
So once you get these files, you can you can double click them, double click on left, double click, and automatically in the command window, this command will get executed. That means that data gets loaded. So workspace means all the variables that you are working with will appear in the workspace. Okay. It is better that you keep these panels open, the workspace, command window, and if you are writing a code, the script as well. I'll show you how to do that later.
Sir, this I could download, upload these 2 files, sir, frequency and step response.
Now just double click on the frequency response data. And
no, sir, I just wanted to download this also. Na? What I mean to say is
my spectrum.
script M. Yeah, just a minute, sir.
Maybe you can share your window. Is there any problem?
Just a minute, sir. I'm just doing it.
Hmm.
When I'm clicking on my experiment, is getting the file is getting opened. I have to
Don't
save
click.
it. What?
Yeah. When from the Google
Save as.
Classroom when you
Yes,
download,
sir.
is
Yes,
it?
sir. Yes, sir. Yes, sir. Yes, sir.
Oh yeah. First, better you save it in your system and then upload. I mean, open it from here. Anyone else has done it?
Yes, sir.
Yeah, we have done it. We have done it.
Okay. Then I'll proceed. So, so when you double click on the frequency response data, this command will get automatically executed, and on the workspace you will see that these data files, data variables are loaded. So now, so what are these? Double click on one of the variables. Now you will be able to see that. So for each of these variables, so in the problem statement PDF, I have specified how to read a data file, right? Like what does f underscore 0 underscore 1 represent? What does this file contain? So here f underscore 0 underscore 1 is the frequency response of the system when we are giving at 0.11 hertz, right? Similarly, the second file 0 underscore 2 is 0.2 hertz, 0 underscore 3 is 0.3 hertz, and so on till we have 1.2 hertz. So till 1.2 hertz we are giving the input, and then we are recording the output. So to visualize it, we can plot the data to visualize it. So if you are familiar with MATLAB, you can plot. So are you familiar with the MATLAB commands like plotting and all?
Sir,
We are used to Excel.
we are used to Excel, but most of the people know, some 60% of the people knows that, but person like me and all from zero.
No problem. So I'll give a basic understanding. Okay. So in MATLAB, every variable mostly is a matrix. So mostly we work with matrices. That's why MATLAB is a very powerful tool because it makes working with matrices very easy. So matrices and matrix operations. So here, let us say I have a variable. I'll give a brief introduction of how we deal with, how we do the operations here. So let us say I have a variable A, and I'm defining it as a matrix. So matrices can be defined by using square brackets. So let us say I have a matrix called 1 comma 2. So 1 comma 2 means this is a matrix with one row and let us say, yeah, this is a matrix with one row. You can see A is a one row matrix. So now to separate rows and columns, we use to define in the next column we use a semicolon. So now I have 2, 3, 4, 5, 6. So now I have defined A to be, what is the dimension of this this variable a in the latest with the latest values, what is the dimension?
2 by 5.
2 by 5, right? So two rows and 5 columns. So this is how we define a matrix. Understood, right? So rows are, elements of rows are separated by comma, and columns are separated by elements in the columns are separated by commas, and when you go to the next, when you want to define the next row, you will put a semicolon, right? So now I have a. Now I want to access some of the elements in this a matrix. So let us say I want to access the variables present here 3, 4, 5. So what are the indices of this? What is the index of this 3 here?
1
It's
comma 3.
basically 1 comma 3. Yeah.
1 comma 3, right? So 3 is present at 1 comma 3 and 5 is present at
1 comma 5.
1 comma 5. So if I want to go from 1 comma 3 to 1 comma 5, what I'll do is, for indexing of a matrix, we use parentheses. So 1 comma, that is I'm telling first row, and the columns, which column? 3 to 5. For telling it go from here to here, we use a colon. Okay, so I have what I'm doing, what I'm telling MATLAB is, in the matrix A, select the first row and go from column 3 to column 5, right? Now if I execute it, it will give me the 3, 4, 5 which are present here. Understood?
Yes, sir.
Yes.
Yeah, again, if I want to print all the variables present in the second row, right? So for all the variables, just putting a colon will be sufficient. So second row, so 2 comma all the columns, right? So what I'm telling here is, go in matrix A, go to second row and give me all the variables present, all the columns in second row. So if I execute that, I'll get 2, 3, 4, 5, 6, all these elements. Understood? So now we'll go back to our plotting. So now we have loaded our f_0_1 f01 matrix, right? So now the command to plot graphs in MATLAB is plot. Here first is our x coordinate, right? So here x coordinate is our time. So here in this variable, the first column is the time, second column is the input, and third column is the output. What are our input and output here for our system?
When a frequency response also, it will be j omega, like what I'm saying, sir. No, sin omega t and cos omega t. It's an additional function actually.
No. Here in our, see, this data is obtained by just giving an input and output to the system. Input, what are the input and output quantities? I mean, what are the physical quantities of input?
Voltage, sir.
Yeah, voltage is the input and pressure is the output, right?
Right.
So when I want to plot with respect to time, so what I'll do is f01. So I want to plot all the points in the first column, right? So comma 1. So this, what does this say in f01 matrix? Plot me the first column, all the elements, right? And with what? With the second column, all the elements. So understood what I did here? Plot will give me the plot between a comma separated arrays. or vectors, I can say. So here, these are two vector quantities. Vector quantities means there are only it's a row vector or a column vector. Only one dimension. One dimensional matrix is a vector. So here, I am plotting with respect to time my input values, right? So if I plot it, it will give you, it will generate a figure. You can see. Yeah. Are you able to see this figure?
Yes, sir. Yes, sir.
Yeah.
Yeah.
Are you able to execute like the plot yourself? Just try it once.
It has come, sir, like this only. Yeah.
Okay. So now we want to plot both the input and output at the same time, right? So this plot has given me time with input. Now again in the same plot I want to put time with output, right? So what I'll do is my third column. So this will give me time with input and this will give me time with output in the same plot. Yeah, here you can see. So the blue curve you can see is the input voltage, and the red curve is the output pressure with respect to time. Fine. Any doubts still here?
No, sir. It's going good. No problem.
Okay.
Just 1 minute.
Yes.
Sir, just to ask one thing in between, like what I'm going to say, if I want to plot the output also on the same the chart, I can use also the hold on. What I'm going to say is command, na, if I'm not wrong, right?
Yeah, hold on command also you can use. If you're hold on also, hold on, what it will do is first it will generate a figure, and then to generate the next figure it will hold on to the same plot and then generate it.
Okay.
Either way you can do, either way is fine.
Right, sir. Right.
I'll suggest that when you get time you explore these things like the basics of MATLAB and get familiar with these kind of things like how to plot, how to give the labels, how to give the legend, and so on.
Sir,
Okay.
one request I have, if you can share some YouTube link where we can find this type of, I would say, basic thing, that will be great. Just a request. Or
Yeah, MATLAB itself has generally one YouTube link will be difficult to get all these basic things. Better is you search the documentation. That will be a good. Let us say I don't know how to plot things on MATLAB, so I'll just go plot MATLAB and I'll go to the documentation. So here you can see all the ways you can plot. So what will I get when I plot x comma y? How to give the variables, and then how to add legends, how to save it as a figure, how to get multiple plots, then how to get dashed line with different, specify the color, specify the whether it's a line plot or a dotted line plot, and all these things you can find in the documentation. So the YouTube video, like MATLAB will have YouTube videos, but they are specifically for generally they require YouTube videos for more complicated stuff rather than these things. So these things it is better to learn from the documentation itself.
right, sir. Thank you. Thank you, sir.
Anything, any doubt you have, just go to Google and it'll take you easily to the documentation, the respective documentation where you will get the required details.
Cool, sir. Thank you.
So, shall we proceed?
Yeah, let us proceed. Yes, sir.
Yeah. So here we have plotted the time varying plots of the input and output. Right now, see what is our aim. We want to see if our what is the one condition for a linear system. When we give an input at a given frequency, you must have learned it in the introduction to Bode plot lecture, I think, that the output will be also with the same frequency, right, for a linear first order system, right? So
Right, sir. Right, sir.
yeah, so to get that frequency, the dominant frequencies of whether to see that whether our input and output are at the same frequency, what we'll do is we'll do a discrete Fourier transform. So you must have be familiar with Fourier transform. Fourier transform, what it does is any function, it will break it into its component sine and cosine waves. So if I have a periodic function varying arbitrarily, so Fourier transform, what it does is it will break that function into sines and cosines of different frequencies. So if I have, let us say for example, if I have a step function, not step function, a square wave. So if I have a square wave, square is a periodic wave, right? So if I do a Fourier transform of that, I'll get the required sine and cosine components, which when I add together will give me the square wave. So like that, any function, any periodic function can be broken down into its component sine and cosine waves, pure sine and cosine waves. And this discrete Fourier transform will tell us what is the amplitude and frequency of those sine and cosine waves which have to be added to get the required function. Is this clear what a Fourier transform does?
Sir, read it about this, but probably we'll revise once and try to understand in a better way.
Okay. So I'll try to draw and show you maybe. Okay, I'll try to explain a little bit better, and you can go back and see other resources which will explain it more clearly, like in a more mathematical perspective. So here, if I have a periodic wave, for example, you're able to see my screen, right? The paint window I have open.
Yes, sir. Visible.
Sorry, the drawing won't be very fine because of I'm using the mouse only. So let us say I have a square wave, right? Let us say I have a square wave. So this square wave is a periodic function, right? Of period, how much? Let us say I am repeating it every. This is pi and this is 2 pi. So this square wave is with a period 2 pi, right? Period means after how much time interval it is repeating itself. So now if I perform a Fourier transform on this, what I'll get is I'll get the sine and cosine waves which which when I add like this is one of the sine wave with this amplitude and this frequency. So I'll get the sine and cosine waves, which when added will result in this square wave. Is it a little bit clear now?
Yes, Abhinav.
Yes, yes.
Okay, so if you want to get a good understanding of this, there is a video by a YouTube channel called 3 Blue 1 Brown. So that there the person explains it very clearly what a Fourier transform does and why it does. So this is the basic function of a Fourier transform. So here, yeah. Now I am loading my spectrum. Double click on my spectrum file and it will open the script file, right? Now if I execute this my spectrum, and give my input and output here for my spectrum. See, okay, I'll tell you how a function works. So in any programming languages we have functions, right? So in MATLAB also we have functions. The syntax of function is like this: we define the function by writing function, and then we put the output variables that have to be returned. Then we give the name of the function, and then we give what the input arguments it is taking, right? So here, when I define the function like this, so what I'm telling is this function's name is add. It will take two input arguments named x and y, and it gives me output variable called a. So if I define my function, and under this I'll define my function named like this. Let us say I'm doing an addition, and I'll end. So this is a simple function which adds two variables x and y. Now if I want to execute my function, right? So first I'll have to save it. First I'll have to save it. Then what I'll do, I'll call my function with the input arguments, let us say 2, 5. So I am passing 2 and 5 to my function and telling them to add. So the answer is, it has returned me a variable called a, which is equal to 7 by adding them. Okay, is it fine? How a function works in MATLAB, like the syntax and all?
Yeah.
Okay, so now here my spectrum is also a function like this. So sorry, yeah, my spectrum is also a function like this. Here in my spectrum function, the input arguments are x and y. So the arguments which are giving is our input and output. So for each of these f01, f02, f03 has inputs and output variables, right? So that is what will give as the input arguments for my spectrum. Why are we giving this? What is our aim to obtain from my spectrum?
That will tell us, sir, whether the input and output frequency are matching or not.
Yes. So ultimately, we want to see whether the input and output frequency, like when we do the Fourier transform, I'll get the sine and cosine waves that are inside this periodic function, and then I can verify whether I am getting my input and output with the same frequency, and like the is my input and output reaching the same peaks at the same frequency and so on. So if I plot this my spectrum with these, sorry, okay. Here I have no output arguments. Okay, so now you can see this figure. Your my spectrum figure will look like this. This is what is called a stem plot. Okay, yeah, a stem plot is like this. So here, what does the stem plot show is, on the horizontal axis you have the frequency, and on the vertical axis you have the amplitude. So here you can see from the legend that the dark blue values are of the input and output is the magenta or pink one, I think. So you can see here that what is the frequency here. If you hover over here, you can see that the output variable is reaching the peak at 0.1 hertz, and the peak amplitude is 2.4. And similarly, the same way, the input quantity is also at 0.1 hertz, and the amplitude is 2.7 is its amplitude. So the units are, input is voltage, so volts, and output is pressure, so bar. They are the units. So now, now we have seen that we know that we have given a cyclic input of 0.1 hertz. That's why, as expected, we can see that both the input and output are reaching the top. I mean, reaching the peak at this this frequency 0.1 hertz. Similarly, you can plot for every set, every frequency, like 0.1 hertz, 0.2 hertz, and so on, and record the amplitude. Why are we recording the amplitude? From this, we understood that they are reaching at the same frequency, right? Now, so from this, it is clear that it is an LTI system, right? Next, what should we find out is whether it is a first order or a second order system. To decide that, we go for the Bode plot, right? How do we get the Bode plot? The Bode plot is essentially you can see the PDF here. So Bode plot, the gain plot of the Bode plot, here the output of amplitude by input amplitude plotted with the a semi-log plot will give me the Bode plot of the input and output variables, right? That's what we do, no? If I have a transfer function, I'll find g of j omega, right? And I'll plot the magnitude of g of j omega with respect to omega. And what insights do we get from a Bode plot? When I plot with respect to the frequency, I can tell that if my Bode plot has the asymptote of a Bode plot decay is minus 20, I can say it is first degree or a first order system. And it's if it is minus 40, it is near minus 40, it is a second order system, and so on. So that is why we are going for this data in the my spectrum plot, where we are recording the amplitude of each of this spectrum. We are, so the peaks we get, and the ratio of this will give me this quantity, the output by input, right? Then apply the 20 log, and I'll get the gain for that frequency. Understood? Any doubts here?
It's fine, sir. It's okay.
Okay.
Clear,
So,
sir. Clear, sir.
Yeah, what you'll do is,
Just for clarification, in that
yes.
input data sheet, those first three columns are what? Three columns continuously. First column is what? Second column is third column.
So here, the first column is time.
Got it. Okay. Each
And
time
the
step.
Yeah, each time step. And the second column is my input, that is my voltage. Third column is my pressure.
Got it. Thank you. Sure.
Okay. So now you can either manually record by plotting each of these and getting the the peaks, or you can write a script file where uh, I'll show you a sample file I have written just for example. So here I have defined a variable, I mean a matrix A, initialized with zeros. So zeros is a command which initializes the matrix with all the zeros, right? Now, and for each of these, uh, in each step, I am plotting for 0 0.1, 0 0.2, 0 0.3, and so on. I am plotting the my spectrum, right? With these input frequencies for those specific frequencies. I'll run this and show you. Just a second, it is taking some time. Just a second. There's some error here. Yeah, you can see now that I have plotted all of them in the same script file, and record these amplitudes. So essentially we want the ratio, that is input, that is output by input, to get my gain, right? So this output by input is the ratio of the peak output by peak input value for each of these frequencies, right? Then what I'll do is I'll plot a semi-log plot in the command window. You can give a semi-log x, because for Bode plot we use semi-log plot, right? So a semi-log x is the function we have. Just a second. Yeah, sorry about that. So the semi-log x is a function which we use to get a logarithmic plot, right? So here we have our frequencies ranging from 0.1 to 1.2, right? So that I can give using directly you can give as an array, or you can give what is called a linspace. So linspace is short for linear space. So here linear space is a function which will generate a vector from a value to a value with these many values. Understood how linear linspace works?
Yes, Abhinav.
Yeah, so here by telling this, what I'm doing is I want to generate a vector with initial value as 0.1, final value as 1.2, and with 12 values in the middle. I mean, a total of 12 values. So that will be my x, and my y will be the gain. So here in my script, I have found the ratios and defined the gain. So here you may do that, or you can manually calculate the ratios and put them in a vector and give that. All right. And then when I plot this, yeah, your plot will look something like this. Your Bode plot. I don't know if this is the same plot for the same values as I have given you, but your plot will look something like this. Then what do we want from here? We will measure the slope of the asymptote at the final frequency, and if it is near -20, I can decide that it is first order system, and if it is -40, I can understand that it is a second order system. Right? Is that clear?
Oh, DSP system to move.
Is that clear?
Yeah.
Yeah, Abhinav, clear.
Okay. Okay. So I think we can stop. Okay. Yeah, time is about 6. So yeah, no problem. We'll stop here. So please try to do whatever we have discussed in this class. Try to implement it yourself. So and as you do, try to understand why we are doing each of these things, right? So the time we have plotted, and then the time variation we have plotted to see, just to visualize the variation of how the experimental data is there. Next we have used the my spectrum function, to get the uh, to get sorry
Abhinav, this PDF shared with us, this procedure PDF.
no, this is I have just made for presenting in this
It's
class.
possible to share with us. It will.
This is essentially like giving you the solution.
Okay. It's okay.
No problem. You try yourself, and we can discuss whatever doubts you have in the next Tuesday's class. Next Tuesday's class is also for this project itself.
Okay.
So you try this, and if you have any thing, you can directly mail me also. That is also not an issue.
Yeah, we'll
right?
do. Yeah.
So this we from the spectrum, for the Fourier transform, we obtain what are the peaks, right? Peaks for each of the frequencies, and then we get the gain for our Bode plot, and the Bode plot will tell us whether it is a first order system or a second order system. Is that clear?
Yeah.
So basically, the Fourier transformation, what we had learned, in our college, is basically suppose we have an analog signal. It will just convert this thing into a discrete signal, right? If I'm not broadly, if I want to just
In the
conceptually,
logging,
okay. So then you're understanding me wrong. I have to just replace it, sir. No problem.
yeah.
Fine, sir.
As I have told, I think well, I can put a link over here.
Yes, sir.
For,
Please do it, sir. We'll just go through it once.
yeah. I'll just put a link where you can find its explanation, detailed explanation. Okay, I'm putting link in the chat. So
Sir, can you share your mobile number also, sir? We cannot.
yeah, sure.
We'll call you like 11 o'clock, 12 o'clock.
Abhinav, can you
Yes.
please mid some question papers, if possible, from sir?
Question paper?
Yeah. Exam question paper.
Okay, I'll ask sir and I'll ask sir and share with you.
Thank you.
Sir, your okay mobile number. I got a. Okay. So we will not disturb so much. Maybe if something required, I will call. Not.
Yeah, no problem. And you can always mail me, even if even if it is a very minor thing, no problem. You can always mail me. Mostly, I will try to reply on the same day, if it is before 5 o'clock, or I'll do it on the next day morning.
Sure. Sir.
And next class will be a little bit faster. This I have taken slowly because to get you familiarized with the basics of MATLAB and so on. Next lab, you please try to implement whatever we have learned in this class, and then maybe you will be able to understand better in the next class also. In the next class, I'll give, sorry, last minute, I'll just take one more minute. In the next class, what we'll do is, so now that we have finalized that it is a first order linear, LTI first order system, verified and justified using this frequency spectrum and frequency response data, and by plotting Bode plot and all. So then, what will be the structure of a transfer function, and how to get the values of those parameters from a step response data, right? That we'll find out, and then after completely finding out the transfer function, then we'll design a PI controller using our root locus tool in the MATLAB. And one more small announcement, the deadline for this assignment will be on 31st March. So you have sufficient time to work on it, right? I'll update it in the Google Classroom as well. Okay, is that fine? 31st March?
Abhinav, we have a midsem of other subject at 23rd of March. So followed by the project midday review also is there. So up to first week of April, we are completely packed. So is it possible to give on before 14th of April?
Okay, then maybe I can give you. Okay, I'll discuss with sir and let update it in the class.
We are okay with the 7th to 10th of April.
Okay, sure. I'll update once I discuss with sir. Okay. I'll update it in the Google Classroom.
Right.
Thank you.
Thank you.
Thank you.
For joining.
Thank you so much, Abhinavji. Thank you.
Thank you.
Thank you, Abhinavji.
Thank you.
Thank you, Abhinavji.